GATE 2018 Civil Engineering Set 1 Question 18. The frequency distribution of the compressive strength of 20 concrete cube specimens is given in the table. So the compressive strength and the number of the cubes with compressive strength equal to that value has been given in the table. 5 such categories are given. If mu is the mean strength of the specimens and sigma is the standard deviation, the number of specimens out of 20 with compressive strength less than mu minus 3 sigma is. The relevant NPTEL reference has been cited. So if we are given 3 categories of concrete cubes whose compressive strengths are given as F1, F2 and F3, and the number of such cubes has been given as N1, N2 and N3. So if we need to find the mean compressive strength, it will be given by summation of Fi into Ni divided by summation of Ni. This is similar to a weighted average calculation as done in statistics. When we need to find the sigma for the concrete cube specimen's compressive strength, what we will do is we will take the root over of summation Fi minus F bar whole square divided by N minus 1. But here what we need to do is, since we have separate categories of certain number, we will find the Fi minus F bar, we will square it and then we would multiply it with N1. Similarly we will do for second category, that is F2 minus F bar square into N2, and we would do F3 minus F bar square into N3. We would add all these values and that would turn out to be summation of Fi minus F bar whole square, which would be substituted in the numerator here, and it should be divided by the total number of concrete cube specimens N minus 1 to get the sigma value. So mean and standard deviation can be calculated as follows, and then any particular number such as mu minus k sigma can be found, using which we can compare the number of specimens that will have a strength less than or greater than this certain benchmark. In this case we have been given the compressive strength of 5 categories, which are 23, 28, 22.5, 31 and 29. The number of specimens have been given in the problem as 4, 2, 5, 5 and 4. So firstly we will find the mean compressive strength, that is given by summation of Fi by summation of Ni. This would essentially be the same as 23 into 4 plus 28 into 2 plus 22.5 into 5 plus 31 into 5 plus 29 into 4 divided by the total number of specimens, that will be 20 as given in the problem. So this would turn out to be 26.575 MPa. Here the compressive strength of the specimens have been given in megapascal and N is a number. Now we need to find the standard deviation, for which we will need Fi minus mu whole square into Ni. So for the first category we would subtract 26.575 from 23 whole square the value and then multiply it with 4. That would give it as 51.1225. Similarly we would subtract 26.575 from 28, square it and then multiply it with 2. That would give the value as 4.06125. Similarly for other categories we will get 83.028125. For the fourth category we would get 97.903125, and for the last category we would get 23.5225. So we should sum all these values and we would get 259.6375. So we know that sigma is given as the square root of summation Fi minus mu square, which is the same as this number, divided by N minus 1. Here N is 20. Substituting the values, we would get square root of 259.6375 divided by 20 minus 1. This would turn out to be square root of 13.665, that is the same as 3.696. Now the question has instructed to find the value of mu minus 3 sigma, which would be 26.575 minus 3 times of the standard deviation, that was found as 3.696. The value comes out to be 15.48. Now we need to find the number of cube specimens that have a f value less than mu minus 3 sigma. Here we can see that none of the cube specimens have a value less than 15.48. All the values 23, 28, 22.5, 31 and 29 are greater. So the number of such samples whose compressive strength is less than mu minus 3 sigma is 0. This will be our answer. So the number of specimens out of 20 with compressive strength less than mu minus 3 sigma was found out as 0. The relevant NPTEL reference has been listed.